Hello, in this video we will discuss problem 5 out of your 6.1 homework. So what do we have here? A man is in a boat 2 miles offshore and he wants to get from his location to point Q on the shore, and what we know here that he is 2 miles offshore and the distance between this point and this 3 miles. So it depends on where he kind of arrives along the shore, either here or here or here. The time might be different. So he needs to make this distance, in this case, this distance in his boat over the ocean, and then we have to he has to walk, and the speed for him to row at in a boat is 3 miles per hour, and he walks at the same speed, 3 miles per hour. Sometimes these numbers are different, so just make your adjustments. Toward what point on the coast should he row in order to reach point Q in the least time, shortest time? So how we can do it? Let's look at this problem once again, and we can look at the bigger picture here that I have for you here. So make sure you understand the problem. So basically we're talking about the path for this man along this dash line and then from here to this dash line. In this particular case, the speed, the rate of the boat and the speed of the man walking on land is the same, but sometimes they are different. So let's see what we have. So this distance is as the hypotenuse of a right triangle here will be square root of x squared plus 2 squared. I show you in writing. This distance as the hypotenuse of this right triangle will be square root of 3 minus x quantity squared plus 1 squared. So when we look at this information on paper, I label for you the speed of the boat, V sub r from row, 3 miles per hour, and V walking, 3 miles per hour. So AO is distance from his current location to the shore here, and it will be x squared plus 4, x squared plus 2 squared. And then distance OQ will be the hypotenuse of another right triangle, and it's here. How much time will the man spend to get from his current location to the point O? That's AO divided by the rate, 3 miles. So and so on. How much time the man will walk from point O to point Q, his speed 3 miles per hour. So we will have this expression. Now, what is the total time he would spend to get from his current location to Q? Total time is given here. It's a function of x. Again, what is x? X is this distance where he wants to basically come to the shore. How far from this point he needs to stop and come to the shore. So we found this function t sub r plus t walking, time walking, will be on these two radical expressions. Then when we differentiate, please, in my case I could take 1/3 as a coefficient outside and differentiate separately this and this. If your coefficient, if your denominator is different, here let's say 2 and 4, you can get both expressions, both radicals with the same denominator first, and then take denominator outside. In my case it's denominator 1/3, in your case it could be 1/4 or 1/6, depends what is the rate here you have. If rate 2 and 4 or 4 and 2, then you know what to do. You have to get both fractions with the same denominator and then take 1 over 4 outside. So let's go differentiate square root of x squared plus 4. We use the chain rule. So the derivative will be 1/2 x squared plus 4 to the degree negative 1/2, which makes this denominator multiplied by derivative of x squared plus 4, which is 2x. And the same here will be 1/2 square root in denominator and multiplied by the derivative of expression under the square root, which is 2 times 3 minus x times negative 1. So here we applied the chain rule twice when we differentiated here. So now we need to find the critical numbers. So we solve equation equals 0. 1/3 cannot be 0, so I multiply by 3 left and right side, 0 by any number 0. And I cancel 2 and 2 here. If your coefficient's still there, don't worry about it, just keep them if you cannot cancel something. So basically I noticed, then I distributed -1 and I got x minus 3 rather than 3 minus x. But then I decided to solve this radical equation as proportion. I moved this portion to the right hand side so a negative sign appears in front, and it comes to negative x again plus 3 or 3 minus x, cross multiplying x times this denominator and then this denominator times 3 minus x. Carefully square the entire left side and entire right side, x squared. When you square this radical, you get rid of square root and have just the expression under the radical. I use brackets to show you. Brackets and parentheses in this case have the same meaning. Again, we square right side, we square 3 minus x, and by squaring this radical you got rid of radical sign, you just have x squared plus 4. Then don't forget that 3 minus x squared is a trinomial, 9 minus 6x plus x squared. If you don't remember special product formula, you can just FOIL 3 minus x times 3 minus x. We will need this expression twice, here and here. So once I open parentheses here, I combine 1 and 9. That's how I got 10x squared minus 6x cubed, because x squared times negative 6x, and x squared times x squared, x to the 4th. Then I multiplied here by x squared first, x squared, I distributed x squared into this trinomial, then I distributed 4, and that's what is the right side looks like. Then I carefully subtracted x to the degree 4 from both sides, because here we have x to the degree 4 and here we have. Then I added 6 to x to degree 3 to both sides, and I don't have any more 6x cubed. Then I have 10x squared equals 13x squared minus 24x plus 36. It's a quadratic equation. I subtracted 10x squared, I got 3x squared minus 24x plus 36. When you can use here either factoring, you can factor 3 outside and have x squared minus 8x plus 12, and it's easy to factor, or you can use the quadratic formula if you want to do that, because factoring sometimes tedious for students in calculus. So you got two answers, 6 miles and 2 miles. We need to check, are these both answers in a domain of solution? Let's look. What if x is 6 miles? Does it make sense? No, it does not, because 3 minus 6 gives you negative 3 miles. So 6 miles will be way over here, and the entire distance between this point and this 3 miles. So as 6 as a solution of the quadratic equation, it's not a solution to the problem, since 3 minus x must be positive. And 2 miles look good for this problem. If we have 2 miles here, we have 3 minus 2, 1 mile here. So everything looks great, normal. And we check if 2 miles give you minimum for the function. As we remember, the function is f of x over here, and it represents the total time. To check if it gives you minimum, you have to go to the expression that you got when you differentiated f prime of x. F prime of x will be 1/3 quantity this. So if 1/3 is positive, so the sign of derivative will depend on the quantity of this expression, x over square root of x squared plus 4 plus x minus 3 square root 3 minus x squared plus 1. So if we plug in anything to the left of 2, I will choose 0, for instance. Why not? 0. So we got this one 0, and here we have negative 3 over square root 3 squared plus 1. It's negative 3 over positive, so the derivative negative. And when you plug in something from here, you got x equals 3, you got this one is 0, and here you have 3 over square root 3 squared plus 4, so positive. So that means that function here is decreasing and function here increasing. So that means that at x equals 2, the function f of x, which is our total time, has a minimum. So answer the question, x is 2 miles. So the boat needs to be here if the man wants to have the shortest time. I hope it was helpful, and